Prometheus, metrics-based monitoring for cloud-native systems. Agenda: Metrics monitoring models. Prometheus history. Why Prometheus? Script lifecycle. Getting started. Basic workflow, PromQL, and alerting. Metrics monitoring. Metrics monitoring tracks numeric measurements over time, request counts, latencies, memory usage to understand how a system is behaving. If a service starts degrading, well-chosen metrics reveal the trend long before it turns into a full outage. Almost every production system needs some way to observe its own health continuously, not just when something breaks. Any team running distributed services benefits from a consistent way to collect and query metrics across all of them. Manually checking dashboards or logs to spot a slow decline doesn't scale. Push-based and pull-based metrics collection. A push-based system has every service actively send its metrics out to a central collector on its own schedule. Prometheus instead pulls metrics, scraping a known HTTP endpoint on each target at a regular interval. Push-based StatsD, Graphite service sends metrics out. Pull-based Prometheus scrapes metrics endpoint. Missing target is obvious. Problems with push-based metrics collection. Single point of failure. A collector that goes down can silently lose incoming metrics, requests metrics, with no way to know what was missed. Every service needs to know the collector's address and manage its own retry logic. Hard to tell whether a missing metric means the service is down or just failed to push. Misconfigured or buggy services can flood a central collector with unexpected traffic. Difficult to control collection frequency centrally since each service decides its own push interval. Misses out on a simple way to verify a target is even reachable in the first place. The Prometheus monitoring system. Applications expose current metric values on an HTTP endpoint, typically slash metrics, in a simple text format. The Prometheus server discovers targets and scrapes data that endpoint on a configurable interval, storing the result. Alert Manager receives alerts from Prometheus and handles routing, grouping, and deduplication before notifying anyone. Other similar monitoring systems: Graphite, InfluxDB, Datadog. Prometheus advantages: pool-based scraping makes it obvious when a target is unreachable, rather than silently missing data. A powerful query language, PromQL, makes it easy to aggregate and analyze metrics on the fly. A multidimensional label model lets metrics be sliced by service, instance, region, or any other dimension. Service discovery integrates natively with Kubernetes, letting Prometheus find new targets automatically. Alert Manager separates alert routing and deduplication from the core metrics engine. Backed by the CNCF Cloud Native Computing Foundation and one of the most widely adopted monitoring systems in cloud native infrastructure. Everything is a time series, almost. One huge benefit is that in Prometheus, almost every measurement is stored as a labeled time series. A metric name plus a set of labels uniquely identifies one specific series, like HTTP request total, method get status 20, HTTP status OK. This multidimensional model lets you slice and aggregate metrics along any label without redesigning your monitoring. Four core metric types: counters, gauges, histograms, and summaries cover almost every measurement a service needs. Because everything shares the same shape, PromQL can query any metric with the same consistent syntax. Metrics and labels. Metric: a name describing what's being measured. Labels: key value dimensions that identify a specific time series. Prometheus.yml: a script config tells Prometheus which targets to pull metrics from and how often. PromQL and alerting rule: a PromQL expression computes a rate and an alerting rule fires when it crosses a threshold. History: created at SoundCloud in 2012 by a team of former Google engineers drawing inspiration from Google's internal Bogman system. Open sourced in 2015, quickly gaining adoption among teams running containerized cloud-native infrastructure. Became one of the founding hosted projects of the Cloud Native Computing Foundation in 2016. Reached a graduated status in 2018, becoming the second CNCF project to do so after Kubernetes itself. Now the de facto standard metric system for Kubernetes and cloud native monitoring stacks. Why Prometheus? Reliable by design. Pool-based scraping makes unreachable targets obvious, not silent. Powerful queries. PromQL supports rich aggregation and analysis out of the box. Kubernetes native. Service discovery finds new targets automatically as they appear. Flexible alerting. Alert manager routes, groups, and deduplicates alerts before they reach anyone. Huge ecosystem. Exporters exist for nearly every common system and language, backed by the CNCF and a large active open source community. The time series database. Prometheus stores every script sample in its own purpose-built time series database. Data is compressed heavily on disk since most metric values change only slightly between scripts. Older data is typically downsampled or expired according to a configured retention period. Never rely on Prometheus alone for years of historical data. Long-term storage usually pairs it with a remote write backend. Prometheus scrape life cycle. Find targets, discover, pull, matrix, scrape, time series DB, store, alert manager, alert. Prometheus discovers targets, scripts their matrix endpoint on an interval, stores the samples, and evaluates alerting rules against them. Getting started with Prometheus. This leads us to the three steps that get metrics flowing. Expose metrics. Add a metrics endpoint to your application. Configure a script target. Tell Prometheus where to find that endpoint. Query in the browser. Use the built-in user interface to run your first PromQL query. Basic workflow. Prometheus operator. Scraping, querying, and alerting. Some call scrape, query, and alert Prometheus everyday loop. Scraping happens continuously on an interval as short as few seconds. PromQL turns raw time series into rates, percentiles, and aggregates in one expression. Alerting rules run the same PromQL engine, firing when a condition holds true for a defined duration. Dashboards, often built in Grafana, visualize the same metrics Prometheus is already collecting. Supports many workflows, infrastructure monitoring, service level objectives, capacity planning, incident response, to name a few. Works the same whether targets run on Kubernetes, VMs, or bare metal. Any questions? Thank you.